Hello, welcome back to Ready Controls. Have you ever wished you could use the old SCP scaling with parameters instruction from RSLogix 500 right here in Studio 5000? But we don't have a scaling with parameters instruction in Studio 5000. So in this video, I'm going to show you how to build your own scaling with parameters add-on instruction set to scale and log signals step by step. First, we will go ahead and create an add-on instruction that takes the PLC raw counts from an analog input card and instantly gives us temperature in Celsius degrees. It's a clean, reusable, and 100% ladder logic compatible AOI. When I first started using CompactLogix controllers, I missed the simple SCP block from the SLIC 500 days. The SCL instruction exists, but it's only in the structured text. So I built my own ladder version, and it changed how I handle every analog input. If you had followed my previous videos in which I talked about a process signal like a temperature which changes from 100 to 600 C and it goes into an analog input card, and the analog input card gives us 0 to 4095 counts, which is a 12-bit resolution. And now we will try to use that example and build our scaling with parameters. So first, to define scaling with parameters, any analog any add-on instruction set, you had to be offline. I'm offline here. I'll right click, create new, right click and create new add-on instruction, and we'll give it a name called we'll just call it SCP underscore ready controls, and we can say this AOI takes input signal and scales it to engineering units, and we say okay, and since we check the open logic and instruction, so we'll go ahead and create. This is the general tab. If you want to see my previous video on how to create an add-on instruction set, the link will show on the top left side. So we'll go ahead and create some parameters. So some of the parameters we're going to create here, let me pull this in the center, is the first thing is we want a input signal. So we just call it input and we make it a real. And then other signal we want is a input min. And again, that's also an input to the AOI, so we call it input here. And then we have an input max. Again, that's a real. And then we'll call it engineering ENG max. And then we have ENG min. And then we have a out, which is a output of this add-on instruction set. So we select output parameter and we call it a real. Okay. Say apply. So we created the required parameters. Now we'll go ahead and build the logic for the instruction, for the add-on instruction set. The logic is simple. The first, as we said in the previous video, we need to calculate the slope. The slope is calculated by taking the engineering units, the range of the engineering units divided by the range of the input. So we'll go ahead and use a compute instruction. So we go into compute math, compute, and we'll say slope, and we'll just go ahead and define a new local tag called slope, and we'll just call it real. Okay, and the expression we're going to use in here is our engineering units max. So we can now click that and then select the engineering max minus, click this to select the tag engineering minimum, divided by input max open bracket input max minus input minimum. So that's the slope. And now we're just using y equal to mx plus c formula where we want to calculate the output, right? So we will use one more compute instruction. We need to insert a rung and then do compute instruction, drop it there, and this would be our output. And this output we call it out, so we'll just use out. And the expression here is we'll take the input minus input minimum. So we'll take input minus input minimum times the slope, which is a local tag, plus the engineering units minimum. So this should give us the output using y equal to mx. M is the slope, x is the input minus input minimum. And we add the engineering units to it. So we will go ahead and save that. So now we created a scaling with parameters add-on instruction set. And then just for the sake of, I'll just go ahead and put it in this routine here. So all we have to do now is drop in some logic where we say use a greater than instruction and say our counts to the PLC. So we'll just call it analog. As we said, our PLC for this process signal gives us 0 to 4095 count. So we just want to make sure it is not negative. So we'll just say analog counts is the counts where we get the input into the PLC. I don't have an analog input card, that's why I'm making up a tag here, which is analog counts. Imagine this would be your analog input card, channel 0 or channel 1 data. So we want to make sure the counts are greater than 0, and then once the counts are greater than 0, we go ahead and move. Greater than 0, we'll go ahead and use the move instruction and move analog counts into our scaling with parameters instruction. So before that, we'll go ahead and create a new, we need to use the add-on instruction set. So if you go ahead and look at the add-on tab here, the new instruction that we created shows up here. And one of the things which we did not do, reason why you don't see any of the tags, is when we set up this open definition here, we did not select what all are visible. So we'll go ahead and select the required. We need the input minimum, input max, input engineering unit. And once we select them as visible or required, they will be visible. So we say apply, yes. And once we go back into our add-on instruction set, you could see all of these showing up. So we'll just create a tag, call it temperature, and we create a new temperature, and it would be of data type of add-on instruction set, SCP ready controls. We go ahead and create it. So now if our counts are greater than that, we have to move into input right here. So the way how we do this one is we just call it temperature dot input, right? So that value goes into the input of the AOI, which is temperature is the name of the AOI, and that will go directly into the input. And input min and max, as we said, our process goes from 100 to 600, 100 to 600. So 100 is the minimum and 600 is the maximum. And our engineering units, sorry, inputs are 0, and we go 4095 counts. And engineering units are temperature goes from 100 to 600 Celsius, and output would be calculated by the AOI. And input here is out temperature maybe. Okay, and for the input for now, let's use just analog counts, and then we'll write a condition where we can drop this analog counts. If I just make it 0, what will happen? Okay, yeah, I'll just make it 0 there. And then when that instruction executes, it should move into it. Okay, so all we did was write a condition where If it's greater than 0, then we move it. Later we'll come back and add. If it's greater than 4095, we will clamp it to 4095. So that's how we created a basic scaling instruction. Now let's download this to the PLC and see how this one works. So after downloading the AOI, there is one thing that we need to ensure in the AOI definition. Make sure you have a bracket right after the slope. So input minus input minimum times slope. Make sure you have one bracket here and then add the engineering minimum. So once we did that, all I did was, we know the input signal ranges from 0 to 4095, and our engineering minimum, which is the temperature, which goes from 100 to 600 degrees. So if I take 2048 as the analog counts coming into the PLC card, that would roughly get to 350C. So this is how we can take the analog input counts and scale it into engineering units. The best part is you can now use this AOI for any analog input. Just change your ranges and voltage signals and level transmitters or pressure sensors. It all works. We just created a fully reusable SCP block for Studio5000, completely in ladder logic. No need of structure text or SCL. You could export this AOI as a .l5x and import it into any project. I will add a link to this in the description, so you could download my version and try it for yourself. If you like this video and you think it added any value, please do like, share, and subscribe my channel. Until then, I will see you in the next video. Thank you.